All right, this is Math 209, Week 2, Section 6.1, factoring a common factor out of an expression on a windy day as I sit in my backyard. All right, so we're being asked to factor this expression, and so the expression is 5x squared plus 20x. So what that means is I want you to think about each of these terms in expanded notation. So that basically means you're going to think of 5x squared as 5 times x times x. You're going to think of 20 as 2 times 2 times 5 times x. Now, how the heck did I get 2 times 2 times 5? Well, I kind of went over here in my head, and I said, well, 20 is 4 times 5, but 4 can be written as 2 times 2, so it's 2 times 2 times 5. And that's what I want. I want it to be completely factored, broken down. And now I'm going to look at these two terms, and I'm going to say, well, what do they have in common? Well, they each have a 5 in common, and they each have an x in common. So that is your common factor, your greatest common factor. So we're going to factor out a 5x, which is kind of like the opposite of multiplication. It's really division. So when we factor out the 5x, what are we left with? Well, we're left with x on the inside. And this plus comes straight down. And then, when we factor out the 5x, what are we left with? Well, we're left with 4. Now, where the heck did I get the 4? I put the 2 times 2 back together again. So I did 2 times 2, and that gave us 4. And so, there is our factored version of 5x squared plus 20x. All right, more of the same. So we're going to do 12y cubed minus 4y squared. All right, so what are we going to do? Well, we're going to think of 12 as 2 times 2 times 3, and then y times y times y. Oops, I forgot that little time sign there. And then we're going to think of 4y squared, so it's going to be minus, and then it's going to be 2 times y times y. So all I did was I took this and I wrote each of the two terms in expanded notation. And if I want to make sure I did it right, well, 2 times 2 is 4, times 3 is 12, woohoo! Y times y is my y cubed. And then over here, 2 times 2 is 4. And then y times y is my y squared. So far I know I'm right. So now I'm going to look for my common factors. And I see, hey, this has got 2 2's, this has got 2 2's. And then I see that this has got 2 y's and this has 2 y's. Yes, this guy has an extra y, but he doesn't. So that's why we can only underline 2 of the y's. All right? So now I'm going to factor out our common factors. And our common factors is 4y squared. Where the heck did that come from? Well, 2 times 2 is 4. Y times y is y squared. So when I factor out the 4 and the y times y, what am I left with? I'm left with, on the inside, 3y minus, and then when I factor out the 4 and I factor out the y squared, what am I left with? Well, it looks like nothing, but the real answer is I'm left with 1, because really we're dividing. So when you divide something by itself, you get 1. And so this is your factored version of this. Now, how could you check to make sure you're right? Well, you could use the distributive property and multiply 4y squared times 3y, and then 4y squared times 1. And if you did it right, you would end up with where you started from. So this is more of the same. It's just getting fancier. So we've got 24x squared y squared minus 4x y cubed. All right? And so I'm going to think of this as, let's see, 2 times 2 times 3. Nope, I lost a 2. 2 times 2 times 2 times 3, so that's 24, times x times x times y times y. So that's the first term. in expanded notation. Now let's do the second term in expanded notation. So that's going to be, let's see, 2 times x times y times y times y. All right, so what do we have in common? Well, we've got two 2's, and we've got a police car. We've got an x and an x, and then we've got y times y and a y times y. Rockin'. So what's our common factor that we're going to be factoring out? Well, it's going to be 4xy squared. 4xy squared. All right? So when we factor out the 4, and we factor out the x, and we factor out the y squared, what are we left with? We're left with 6x. Where did the 6x come from? Well, the 2, the 3, and the x that were left. And then this minus sign comes right there. And then the next term. Well, when we factor out the 4, we factor out the x, and we factor out the y squared, what are we left with? Just a y. And that is our factored form. This is the exact same kind of stuff. They're just kind of asking it in a different way. So they're saying, okay, you got 6y to the 4th minus 2y cubed. And if you think about it in expanded notation, you got 2 times 3 times y. And a lot of our students doing algebra are asking themselves, why? So you got 2y. And so what's our common factor? What's our common factor? A 2 is in both. And then we've got a y and a y. So that's a y cubed, right? So what's the greatest common factor? Is 2y cubed. All right, so that's the first part of the question. But then they're asking us, okay, well, now factor. So you've got 2y cubed is the common factor that we're going to pull out. And then, so what are we left with? On the inside, you got a 3y for our first term. And then that minus sign comes over. And then everything got factored out of this second term. So that means 1 is what's left over inside that quantity, inside that parenthesis. All right, so now we're going to identify the greatest common factor. Now, what's different about this one is they've got 3 terms, but it's the exact same process. Now, I'm going to see if I can kind of shortchange us a little bit. Using my multiplication facts, I see that for a coefficient, the largest number in this, and this is 4. All right? And then I can see that in terms of the variables, I can see that this has an x, this has xx, and this has xxx. So the only thing in common in all 3 terms is a x. All right? So when I factor out a 4x, this guy becomes, well, let's start back here. So when I factor out the 4, what's left of the 20? 5, because that's like division. 20 divided by 4 is 5. Now when I start with the x cubed and I factor out an x, what am I left with? X squared. And then this plus comes over. And then let's start with the 16. When I start with the 16 and I factor out a 4, what am I left with? 4. When I have the x squared and I factor out an x, what am I left with? An x. And then the plus sign, because this plus sign comes over. And then when I start with a 4 and factor out a 4, what am I left with? 1. When I start with the x and I factor out the x, what am I left with? 1. So that third term becomes just a 1. And there is my answer. All right, so starting with this ugly polynomial, x to the 8th minus 6x to the 7th minus 3x to the 6th. And if I'm going to factor this out, I see that there's no coefficient that is common in all of them. Because this has a 3, this has a 6, and this has just a 1. So technically, it's a 1 that is that's in common. So we're not going to do that. That's trivial. So let's look at the variables, and we see that this has x to the 6th, and this has x to the 7th, so that's 1 extra. And this has x to the 8th, so it's 2 extras compared to that x to the 6th. So the greatest common factor is x to the 6th power. So that's what we get to factor out. So when I factor out x to the 6th from this first term, I'm left with x squared minus, when I factor out an x to the 6th, I'm left with an x, 1 extra x. So that's going to be minus 6x. So there's my minus 6x. So that minus just comes over, and I've got a 6x, and then I've got a minus. And when I factor out the x to the 6th power, I'm left with just a 3. So it's minus 3. And there is my factored form. Now, how can I check it? I could multiply. I could use the distributive property. And sure enough, I would end up back where we started from if I use the distributive property. So that's how I could check if I'm right. So here, identify the greatest common factor, then factor. So it's just more of the same, only it's getting longer and more laborious. All right, so 4x to the 5th minus 6x to the 4th plus 4x to the 3rd. So I'm going to kind of do it right underneath it. Actually, let's move it over here. Good. So I'm going to do that right underneath. So what is in common? Well, they're all even, so they can all be divided by 2. And so sure enough, the coefficient 2 is a common factor. And I see that all of these contain an x to the 3rd power. So our greatest common factor right here is 2x to the 3rd power. Now let's factor. So when I divide out from this term a 2, I get no coefficient, so the coefficient is 1. If I have x to the 6th and I factor out x to the 3rd, I'm left with x to the 3rd. Now in here, when I start with a 4 and I factor out a 2, I'm left with a 2. And then when I start with the x to the 5th and I factor out x to the 3rd, I'm left with x to the 2nd. And then minus, because this minus comes here, this plus comes there. And then, so when I have a 6 and I factor out a 2, I'm left with a 3. When I had x to the 4th and I factor out x to the 3rd, I'm left with an x. Now this plus comes right here. And when I have a 4 and I factor out a 2, I'm left with a 2. When I have an x cubed and I factor out an x cubed, I'm left with a 1. So I don't need to write anything down, and there is our answer right there. All right, so let's start with 2cb squared minus 2bc squared. So what do they both have in common? Well, they definitely both have a 2. They both have a c, and they both have a b. So our common factor is 2bc. I like to write things in alphabetical order, so I like to put my b in front of my c. It's optional, but that's how I do it. So when I factor out the 2, and I factor out the c, and I factor out one of these two b's, I'm left with b. And then I got a minus, because the minus comes right there. I factored out the 2, I factored out a b, I factored out one of the c squareds, c times c, so I'm left with minus c. And that is our factored form. And man, they're just getting ugly. These are just ugly, ugly, ugly. So you've got 7x to the 6th, y to the 8th, plus 14x to the 7th, y to the 7th. Man, it's windy. Sitting outside, it's gorgeous, and it's all windy as all heck. Okay, so what do we have in common? Well, I see a 7 and a 14, so there's a 7 in common. And then I see that this has x to the 6th, this has x to the 7th, so they have an x to the 6th in common. And then I see that this has y to the 7th, this has y to the 8th, so they have a y to the 7th in common. And so that right there is our greatest common factor. So now let's factor. So when I take out a 7, I take out an x to the 6th, and I take out y to the 7th from this first term, I am left with just a y. 7 divided by 7, x to the 6th divided by x to the 6th. So all that like cancels out. And then 7 of these y's cancel with 8 of these y's, so that leaves me with just y, or y to the first power. And then plus, because it said plus. Now I had a 14, but I factored out a 7, so now I'm left with a 2. I had x to the 7th, but I'm taking out 6 of them, so I'm left with just an x to the first power, or x. And then here's y to the 7th, but I'm factoring out y to the 7th, so I am done. There is my factored expression. And this is practically the same as the previous problem. So you've got 7r to the 6th, t to the 6th, minus 14r to the 7th, t to the 5th. And I can see that we have a 7r to the 6th, t to the 5th in common. And so when I factor out, that goes away, that goes away. 5 of these goes away, so I'm left with just a t on the inside, minus, and then this is a 2, because when you have 14 and you factor out a 7, you're left with a 2. We had r to the 7th, but I factored out 6 of them, so that's an r. We had t to the 5th, and I am factoring out t to the 5th, so we're done. So I am officially factored right here. So what was the greatest common factor? This part was the greatest common factor, and then this whole thing is your factored expression. And that wraps up this video.